All right. So let's get started back. I want to talk about refactoring again a little bit. So we constantly have to refactor and get better at what we do. Now I want to put two things to perspective here about refactoring. Refactoring is something constant. We have to do this constantly. So as we are creating software, we should constantly refactor what we create. Well, Frederick Brooks wrote, and this has been written several decades ago. If you ask me, what is software development? I'm going to say software development is a violent process by which we repeatedly try to disprove Frederick Brooks, and we fail at it every single time. Because that's what I see people do, right? Oh, what does this man know? And they do stuff, gosh, that failed, but we're going to try it again. Well, he nailed it. He said, develop a piece of software, and when you're done with it, throw it away and start again, and now you have a chance of doing it. And of course, you don't dare to go to your boss and say, boss, I've got a great idea. I know exactly how to develop a successful software. Your boss says, how? We will build it, and when we are done, we'll throw it away. That's the easiest way to get fired, right? Nobody's going to hire us for doing that. But does it mean that Frederick Brooks is wrong? No, he's actually absolutely right. But what if we don't throw it away as in the entire software, but what if we throw away every little piece we create and rebuild it? Because we learn by active prototyping, we learn by experimenting, we learn by doing things, and that is something we have to really start doing quite often. I was listening to the guys doing Datomic, which is a product from the Clojure community, and they said they built Datomic 4 times before they got it right. Can you imagine this? They built it once and they completely threw it away and started again and threw it away only to start it again. About the 3rd time they begin to say, we are almost there. And then they built it entirely from the ground up one more time, the 4th time. Not everybody has that luxury of, or the courage, I should probably say, of throwing it away and starting over. But I remember in my own experience, the time that I felt really good, well, actually it's a little bit of a dilemma because it comes after a lot of stress and tension as well. I remember recently taking a very long flight. It was about a 20-hour flight, and I was on this very long flight, and when I got into the flight, I said to myself, I'm going to go ahead and implement this very critical feature. And it took me about 16 hours through the flight to actually implement it. At the end of the flight, once the code was working, I realized this was a piece of crap. I don't like it at all. So the minute I landed and went to the hotel, it was like 2 a.m. and the most stressful time because I'm looking at this code and part of my mind says, this is nonsense, delete it. And the other part of my mind is like, dare you not? You took so much time to write it, keep it. And there was a tension for a while, and then I just, boom, deleted it, gone from the face of earth. It felt so good. And I restart implementing now, and it took only about 3 hours now to implement it after all, because you know exactly what you had to build having gone through that effort, and it was a lot better the second time around than the first time itself. Well, that's a bit of a rewriting. But in times we have to rewrite, in times we have to refactor. But 2 things I want to emphasize about refactoring. You first want to refactor. Second, on your project schedule, you always want to also have some amount of time allocated for really the time to pay your technical debt, to pay back and refactor. Now, this is something we don't do enough in software development. I travel a lot, so I go around the world, and that also means that I'm usually out late in the nights, walking back from a restaurant or late dinner, what have you, and there's a scene that I always see that just fascinates me. During the daytime, I would go sit in a restaurant and have a nice meal, and there's a nice table, chairs and clothes on the table, a very nice environment. Well, after very late night at work or elsewhere, I would be walking back. I would walk back by the same restaurant I had eaten meal at, and what I would notice is that all the tables are there, but the chairs are all flipped on the top of the tables, and the floor's completely wiped clean. And I would stop there and I would say, this is amazing how this business during the day looked very busy with all the people and dining, and in the night, they have completely reworked, and the chairs are upside down, and they have cleaned it up. And I think of software projects. What do we do to clean up? If you think of a software project like a restaurant, all the plates that people ate would still be there on the table, right? And the next person coming in would wipe it clean and sit down and start eating. But that's the way it feels. We're developing software. We don't have these kind of nice practices in our field. We don't tend to really think about this cleanup and restarting phase, and we keep piling on nonsense we do all the time. So we need to take time to think about. We got to take time to refactor, to pay the technical debt. So project schedule should include some time for that as well, for us to be very effective. One of the key things about architecture is I want to think about reversibility. So what is reversibility? Reversibility is the ability to back out of a design decision. So you decided to use something, you decided to do something in a certain way, and now you realize that's not the smartest thing to do. I want to change it. Can you change it? If you can, that is reversible. If you're stuck with it, that's not reversible. And there are certain things that are extremely hard to reverse. Like if I come to you and say, I want you to change the programming language you are using in your project, you're going to laugh at me and say, get out of here, right? Well, you can't change the programming language so easily. Programming languages are extremely hard to reverse. Hey, what about a database? Oh yeah, we could use database, we could back out of databases, we can change the database. Well, databases often are supposed to be reversible. But then you say, yeah, that's great, but what do we do with all these 100,000 stored procedures we have? Oh, tough luck, right? So just because something is possibly reversible doesn't mean it is actually reversible as well. So we need to plan for reversibility. Now, let's ask why reversibility is important. First of all, keep in mind not everything is reversible. There's a cost for reversibility as well, and you want to make sure the cost versus benefit is taken care. Now, second thing, if you are going to make a decision, if I can reverse out of it, I can more easily make the decision today knowing I can change it tomorrow. If a decision is not reversible, I don't want to make the decision now. I want to think about this a little bit more, and I want to commit to it knowing I can definitely stick to it. So when you make business decisions, when you make architectural decisions, ask yourselves, is this decision reversible? If it is not reversible, then wait. Don't make the decision soon, make the decision late. This even includes programming language. Now, of course, you may say, how do you make a decision about programming language? Well, what do we normally do? We say we want to use language X, whatever that X is. Why did you choose that? Because we found programmers who can code in that, right? So oftentimes we decide based on who is available than what's right on the project. And sometimes that's the influence we have. The staffing needs makes a decision. But sometimes we have to ask ourselves, can we postpone that decision until a little later, and maybe we can have some more flexibility. In today's world, almost any platform has multiple languages on it. And how flexible can we to pick other languages? Hey, maybe I can use Java, Scala, Groovy, Clojure, and one of the other languages, C#, VB.NET, F#, whatever that could be. How flexible can we be about it is something to think about. And second thing about reversibility is, I remember this on a project I worked on. This was very, very long time ago, where I was using an object database, and the database, pardon, apologies for me, I'm doing this. Okay, so the database vendor decided to make a significant change to the database in one version. And that affected our product so much, we had to spend 8 months just recoding to get the product to the next version of the database. Can you imagine going to your boss and saying, boss, we're going to code for 8 months, and when we are done, we would give you nothing more than what we have right now. Except, good news, it'll work on this new version of the database. And they were about to fire us. The only thing that kept us there is nobody else could do this. And that was job security built in, right? And it's horrible. And I look back and I said, well, how did we get into this mess? And I realized what got us into this mess. And that is called tight coupling. We were tightly coupled to this database in every layer of our software, in every corner of our software. And we realized when you're tightly coupled, when your surface area is big, a change affects the entire application. And the lesson learned is to really decouple that. And when you decouple it, it becomes a lot easier to work with it. Now, this is easy to say. On another project I worked on, I had a most fantastic boss ever. He came to me and he said, Venkat, I want you to create a solution of decoupling. I know this is a problem. You yourself said this is a problem. I want you to decouple it. I said, no, it's not possible. He said, thanks for that opinion. Now go try. And I tried for about a month. I said, no, it's not possible. He said, try harder. I said, no, it's not possible. And then he's extremely smart. He said, Venkat, thank you very much for your input. I'm going to go hire somebody else who can do it. I said, actually, I can do it. Right? This is a wonderful way to manage projects, right? When you are told that somebody else is going to do it, you're like, I can do it. And I had the solution in about a week. Right? And this is the disbelief we have in our mind. It's not possible. Until you're shown somebody else is going to do it, it becomes entirely possible now, right? And the point really is, we have to really work hard to decouple where it is worth decoupling. And when you decouple, reversibility becomes a lot easier. And if you don't decouple, it's hard to reverse. But there's a cost to reversibility. And if something needn't be reversed, then don't make it reversible and pay the extra cost. We have to be careful about it. But then comes yet another principle I really, really like a lot, which is last responsible moment. Now, don't mistake, this is not about procrastination. I will never say I'm a procrastinator. I'm not procrastinator for a lot of ways. In fact, people actually usually yell at me and say, calm down. Why are you doing all this so early? That's the way I am usually. But when it comes to software, procrastination is not doing what should have been done already. Last responsible moment is, this is now the time to do this. Doing it any sooner is not needed. Doing it any later would become procrastination. So you want to postpone things to a last responsible moment. Now let's understand why we want to postpone things to a last responsible moment. The reason we want to postpone things is, what is the cost of implementing something now versus the cost of implementing something later? Well, first of all, even before considering the cost, let's ask about details. How many of you believe you will be smarter tomorrow than you are today? A few hands go up. Okay, slowly more hands go up. Come on, what about others? You're not going to be smarter tomorrow than you're today? Of course, right? So we all are going to be smarter tomorrow than we are today. That's called hope, right? Absolutely. Otherwise, how miserable life becomes, right? So we all are going to be smarter tomorrow than we're going to be today. Well, why? Because we know more tomorrow about things than we do today, and we refine this knowledge. So there's a benefit to postponing things later. Now, there are certain things we should decide. I'll give you a trivial example. I travel a lot, so I'm around the world constantly, and you can ask me, it tells me it's healthy for me to stand. I like this feedback loop we have here, right? Okay, so the point really is, the idea behind, so the idea behind this is, the whole point about, I want to plan for this travel. Well, what could get very expensive? Well, flight tickets can get pretty expensive. So typically I buy my flight tickets about 2 to 3 months before my travel. Hey, what about a hotel? Yeah, I'll probably do it about a month in advance. Hey, what about taxi reservations, travel? I normally sometimes do it the night before. There are times even I land and realize, oh gosh, I forgot to reserve this. Let me find a taxi or take Uber, whatever it is. So the point really is, if something is expensive, you do it at the time when it's less expensive. When something is not as expensive, you kind of want to postpone it. That way you have flexibility to decide things. So ask yourselves, what's the cost of doing it now? And if that cost of doing it now is greater than doing it later, you definitely want to postpone doing it. Why? Because it's cheaper to do it later. Why do it now with more expense? Hey, the cost of doing it now is equal to the cost of doing it later. What should you do? Postpone. Why do it now, right? Now you say the cost of doing it now is less than the cost of doing it later. What do you do then? Ask y and the probability, right? So the probability What is the probability that we absolutely need it? Well, if it is a high probability, do it now. Low probability, do it later, right? So the point is, if I can postpone it, I would rather postpone it. And if I don't have to postpone it, I can postpone it, I got to do it now. But ask yourselves, what's the probability of knitting? Of course, these are things you can possibly postpone, decisions you can postpone. I'm not saying don't go to work today, right? That's not what I'm saying. Things you can postpone, you want to be able to postpone. Hey, do we need this feature now? Do we need this particular implementation now? Do we need to really connect to this remote system now? Or can we just talk to this other temporary system now? Do we need to implement this other feature security setting now? Do we need to implement this configuration now? Or can we wait for 3 iterations from now? All these decisions we have to constantly ask ourselves. I'll give you an example of this. I worked on a project where my development time was 6 months. So I got to go into production in 6 months. And when I started the development, I remember very clearly on the first day, I sit down to write code. What's the first thing I need? I have to have a database. How could you possibly release a system with no database? And the mere thought of writing database code was so boring. And anybody here likes to work with database schema every day? No, right? No, but no, one person. That's why you don't have any friends, right? No, just kidding. So the point is nobody likes it, right? So absolutely, nobody likes really doing. I'm just kidding. Don't get angry. All right. So basically the point is nobody likes to maintain database schema. Why? Because database schema is like a crybaby, right? Every minute you got to kind of respond to it. Are you okay now? Are you okay now? And it really lowers your agility. So I said, I don't want a database schema. I don't want to deal with this. So what did I do? I decided to use SQLite 3. Now, you know, nobody in the right mind would ever release a product into production with SQLite 3. But I started with SQLite 3. And the beauty is, it's a one file. There's no database management system to deal with. I blow that file away, rerun my test, and it gets recreated. And I had absolute agility. And I went on with this beautiful model. And if you ask me, did I change my database model? I changed it every single day. I changed it several times in a day. And the beauty is, I didn't have anything to hold me back. I could change it any number of times I wanted, and it gave me real good speed. And I was about 2 weeks before going into production. Now you may say, Venkat, you are insane. Well, you're not the only one who would say that. A lot of people have said that. And I said it to myself, I'm insane. And honestly, I was pretty darn nervous by now. Because I got 2 more weeks to go into production. I haven't chosen my database yet. It is SQLite 3 file. Now you may ask me, why were you such an idiot? And the reason was twofold. I wanted speed of development. And I kept developing with it. And the other reason is, I had not chosen until about 2 weeks earlier where I was going to deploy the application. It had to be deployed on the cloud, and depending on whether I'm going to put it on one cloud service versus another, the database that's available may be different. There's a cost associated with it. Technology availability is different. And I had to wait until the deployment model is ready to decide what database I was going to use. So for about 2 weeks now, I knew what database is available because I knew what cloud I'm going to put it on. Now I was getting nervous because this is the last responsible moment. And I came to work one morning and I said, my job today is not to do anything else but to change the database and get this working. And when I got into work, I modified the configuration file, pointed to the database that I want to use, a development database, which is the same as the type of the production database, and I turned it on, and what's the first thing I did? I ran all my automated tests. And 3 of my automated tests failed. And when your automation test fails, that moment is called a moment of panic. And the minute I look at it, it's like, oh my gosh, my test is failing. I got 2 more weeks to go into production. What do I do? I'm like, calm down, Venkat. And all I did, honestly, I'll be very honest about this, I copied the error message, pasted it on Google. The first Stack Overflow entry said, if you see this error, your database definition has a wrong format for string. Okay. And I went back roll back my database to use my SQLite 3, made a change to the database type, reran all my tests, all the tests passed. I switched back to use the production type database, all the tests passed, committed it, never looked back again. I never had to really go back and use SQLite 3 after that. It's been the production type database since. But the point I want to make here is one thing. Why do we make decisions very, very soon often? There's only one reason I can think of why we decide really quick. And there is absolutely no way to deny this, I think. And that reason is called, fundamentally, fear, right? Fear is what causes us. Why are you doing this now? What if this fails later? And fear rules us, right? Unfortunately. And we are worried, hey, you're going to make a decision when? 2 weeks before. Are you crazy? What if it doesn't work? Oh my gosh, what do I do then? But it's even more important. It's not what if it doesn't work. It's usually the question, how do you know it works? Because what do we normally do? We do manual testing, which means you make a change to the system, somebody's got to come there and manually go through. Can you imagine my application when it failed? I'll tell you where it failed. It failed in one of the areas of the system that a user will not go to until they have used the application for at least a few weeks. Which means, had I put into production, I wouldn't even know it's failing until several weeks after put into production. Which means, I'll have failure in production. And when I change the database, you can ask me, Venkat, what kind of manual testing did you do when you changed the database? I did 0 manual testing. All I did was, I ran my automated test, it failed, I fixed, ran all my automated tests, it passed, I said you're ready for production. I never brought up a page to key in and see if it's working. Because if I have to key in to verify the code is working, that's not software development, right? So we can't afford to only manually verify that the software actually works. That's way too late. So in other words, if you want to postpone to last responsible moment, you cannot have that just by itself. It requires other engineering disciplines and practices. One of them is, for example, automated verification. So if you have a fairly good amount of automated verification, hey, you know what? We can change our decision later and we get a really quick feedback loop that things are working. If you don't have automated verification, if your company is doing manual testing for every single thing, well, you cannot postpone to last responsible moment. Why? Because every single one of them just became what? That. Right? Why? It's easy to do now than later. How so? Because it's expensive to test later than to test it now. Look how the equation turns right away if we don't have automated verification. So that is something to think about. We can't just have one thing and walk away. We have to really work towards making that possible. That doesn't come for free. So a lot of these practices are related to each other for that reason. That brings us to the Yagni principle. You aren't going to need it. I often like to put a little extra word here. Why for yet? Because when programmers are told you're not going to need it, they get angry. When you say you're not going to need it yet, they're so happy. Can I do this tomorrow? Of course you can do it tomorrow. And just say the same thing the next day. So the point really is, you can postpone until a later time to the point where you don't have to implement something. And you're not going to need it is a good design principle to use. I often use this when I implement a certain feature. I'll give you an example of this. In a product I was developing, I had this vision for all the things this application is going to do. And I had a list of all the features. And I went to a few of my friends, my confidants, and I asked them, hey, could you please review this feature list for this product? This is what I have in mind. Do you think this is good? Do you have any suggestions? And my good friends went through that and they said, oh, this is a great idea for this particular application. You could do this, you could do that. Like every opinion, they gave me all of this. And I took all that and I said, this is awesome. I know what I want to build. And I went for 6 months and I went into production. Just about a day or two before I went into production, I put it out, didn't announce to the world, but I went back to the same group of friends and I said, could you please log in, take a look at this and tell me what you think? Well, one of my friends came back the next day and he said, hey, looked at this, here are a few comments and things you can improve. But I do have a very important question for you. You sent me a list, about 8 months ago or so, and I saved that list. And I went through the list and compared what you have done to what you had in the list. And I'm a little surprised because I see about 40% of the things that you had in the list in production. The other 60% is completely missing. What's up with that? And I said, that's the whole point. I decided I don't need them. Right? So in other words, to go into production and make money and generate revenue, you don't need everything. And it's been about 5 years now. There are certain features that I had in my original list I have not still implemented today, because the more I think about it, the less value it has today. Second, there are certain features I added along the way. About every 2 or 3 or 4 weeks, I put in a new feature. And there are some features in the original list that were not in the original release or now in the application. But more important, there are certain features in the product that came from directly the active users. When they started using, they go to support or they email and say, it would be so nice if we can do this with this application. You know what? Great idea. I never thought of this feature, but you are the user. And if you think this is going to be helpful, why not? I can provide that feature. So to be able to think about this and say, I don't need to implement YAGNI, you're not going to need it, and postpone it. This is a little feature, little error handling you think you should do, but the error is never going to happen, or very rare, or you don't know how to really simulate it. Things that you can postpone to the point where you don't have to implement. There is a study that shows only about 20% of the features of a software people actually use. Close to 80%, nobody cares. And what a waste of time and effort creating all that feature that nobody seems to be using. We can take an active role in eliminating those and product become much leaner. But what about extensibility of applications? Don't we have to make applications extensible? Oh, absolutely we do. But there's only one problem with it. We don't understand what extensibility really is. We all want to make it extensible, but we don't know what that actually means. Now, I was talking to a team of developers. We were having lunch, and the manager was sitting right in the middle, the team around him, and he said, I want to ask you a question, he said. My team told me every single day that the application they're developing is extensible. Every single day they told me this. And we went into production. About 2 days after we went into production, one of our customers reported a small problem in one of the fields, and so we had to make a change for that. And because our code is extensible, I told my customers, I'll get it to you tomorrow, as managers normally do. And then I came back to my team and I said, we want to make this change, guys. And they said they need a few weeks. And when I asked them why they need a few weeks, they said, we got to change this, and this, and we got to test all of this. And he turned to me and said, how does this make this extensible? So why did they tell me it's extensible every day? And I said, well, it's your fault. He said, it's my fault. What did I do wrong? And I said, the software was extensible until you asked it to be extended. So if you never asked for extensibility, it would still be extensible, right? So that's the world we live in. We aim for this glorious extensibility without knowing what it is. But here comes the problem. How do you know? How do you plan for extensibility? Well, you have three types of people on any project, right? I'm sure you would probably agree with this. The first type of people, right? And you have this combination of people. So you have people, the first type, know a lot about domain, nothing about software. That's the first type of people that are on projects, right? So they know a lot about domain. These are your domain experts, really smart people. But you ask them about software, they know nothing. Then there are people who know a lot about software, nothing about domain. I would say a lot of programmers fall into this category, right? And me included. Then there is this unique, far and few people, you know who I'm talking about. These are people who glow in the dark. Know a lot about the domain and about software. Would you agree? will politely ignore that fourth category. So the point really is, we have these three groups of people in organizations. People who understand the domain really well, but they don't know anything about software. How could they make things extensible? Very difficult, because they don't know what extensibility means from that context. Then there is these people who know everything about software, have no clue about the domain. And what are they doing? They're making all kind of stupid things extensible. And when the business comes back one day and says, what about this? Oh gosh, we never thought of that. The people who can smartly make things extensible possibly is this third group, because they understand both. But they are far and few. So what can we do about it? We can't just simply say, go hire them. So we have to really bring these two groups together. We have to collaborate very closely. When I worked in engineering field that I'm not familiar with, I would often go to my domain experts and say, hey guys, what about this situation? Do you have to handle this? And sometimes they would look at me and they would kind of laugh and say, if we ever do this, we'll violate the law of physics. I'm like, oh boy, we never want to do that, do we? Sorry, but I had to ask. Or sometimes they would say, oh, great question. But no, we don't have to, because we're not going to be in that area of domain. Our domain is more bounded than that. And at some other times they would say, oh, I'm so glad you asked it. Of course we have to handle that. Why didn't we not think about it? But it's our job to collaborate with each other and ask the questions and only plan for what actually makes sense, not just make arbitrary things extensible, because there's a cost to doing it. Ralph Johnson once said, we build hierarchies, we build classes, we build inheritance, we build all these interfaces. Why? Because we want to make the system extensible. But in doing so, we have created so much complexity that when it comes time to make it extensible, that very thing we set out makes it really hard for us to do. So we have to be very careful about this extensibility. It becomes really, really expensive to do if we don't understand what we are trying to really make extensible. That's something for us to keep in mind. In that regard, it's very important for us to focus on parsimony. Parsimony simply says, absolutely aim for the least amount of things you can actually do, and that is something for you to think about. How can you really help to reduce as much as you can? So parsimony says, do not really implement things you don't need. Keep it absolutely minimum. So how can I minimize the number of classes? How can I minimize interfaces? How can I minimize functions? How can I really keep functions small? How can I eliminate libraries and frameworks I don't need? Now think about that for a minute. How many times we start using things we actually don't need? And parsimony says, keep things absolutely to a minimum. In a way, I often apply the Yagni principle and the last responsible moment principle when it comes to parsimony and say, reduce, 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 reduce. Sometimes people get angry at me saying, why are you so eager to get rid of stuff? Because there's one reason. The code you don't write has the fewest bugs in it. Hands down, right? So if you write a piece of code, you got to maintain it. If you don't write a code, you don't have to maintain it. This is what I call as experience. You go to a very young graduate and catch this person on the day to work, the very first day, and say, hey, where are you going? And the person says eagerly, I'm going to work to write a lot of code today. And catch exactly the same person 15 years from now. On the way to work, you say, where are you going? And the person says, I'm going to work to remove code. Right? This is what is experience, right? We begin to learn not to do stuff that's not needed, and that's parsimony. We got to reduce things. That's very important. Now, we tend to do this quite often. We write a lot of stuff we don't need, and it becomes a burden. So every corner you say, get rid of it, get rid of it, get rid of it. I was looking at a piece of code yesterday morning, and I have about 30 lines of code, seriously, 30 lines of code. And I quietly refactored it to 3 lines of code. And then I removed it. And I sent an email back to the developer saying, you can reduce this to 3 lines. Here's an idea, try it. Because I don't want to do it. I want people to learn how to do it. And then when they do it, the first they will tell you, you can't do it. And then they ask you, how do you do it? And then they tell you, wow, it's cool, we could do it. Right? And this is the process we go through all the time. And we can reduce a lot of stuff that we actually don't need. And we tend to write a lot of code. I've had people come to me and say, I can't believe this. I cannot believe how little code we needed to get this working, and we can actually do that by applying this. Don't build hierarchies, triangulate. So, hey, I want to build a set of classes and interfaces. Oh, start building an interface. Bad idea. I once worked with a client where I saw them have interfaces. Every corner you turned, there was interface. I did a review of the code, and I found something a little weird. They had two kinds of interfaces. Some interfaces that had only one class implementing. And there were other interfaces which had no classes at all implementing. And I went back to them and said, this is weird. Why would you have an interface with no class implementing it? And then you have interfaces which have only one class ever implementing. And they said, oh, that's because we set out to write a framework. We ran out of time. And we just implemented minimally what we can do from there. Well, that's a sign. We start implementing hierarchies for no reason. Instead, when you start developing, just write that one class you need. Ken Beck says, triangulate by pulling commonality up rather than writing the interface and abstract classes first. So write this one class, get that working, and a few days later, a few weeks later, whatever, hey, I need to really implement this other class. Oh, that's so much similar to this. Go ahead and duplicate it. Oh my gosh, duplication is a sin. No, it's not. It's a sin only if others see it, right? So don't let others see it yet. So duplicate it. Get the other code working. And once it works, you say, oh gosh, look at this. There's so much common between them now. Refactor and remove the duplication. But when you do that, the commonality that you extract, that you triangulate, is a true commonality, not a perceived commonality. So you're evolving by pulling things up rather than artificially creating things and forcing classes to have those methods and interfaces. So go ahead and write this code and triangulate it and refactor it. Remember, make it work, make it better real soon, and pull it up and triangulate it. Couple of things to think about. Postel's law. Postel's law says, the Postel's law is especially so much more important in today's world of microservices. Postel's law says, design your software in a way it is easy to integrate and communicate without being brittle. And Postel's law really says, be generous about what you receive and be very strict about what you send. Now think about this for a second. If you're designing an interface and I'm going to get data from you, and what am I going to do? The data that I get from you, I'm going to validate and say, hey you, I'm going to verify your schema is correct. This appeared like a great idea 10 years ago. And I'm going to do XML validation, schema check, stop. I'm going to validate your schema. You're good. Come on in. Well, now you say, this is great. He says, I've got two clients. You are one of my clients. I'm sending data to you. But also, he is another client. I'm sending data to him. He comes along one day and says, hey, dude, I want one more field from you. Could you please send it? He's like, sure. I got this data. I can send it to you. He sends the new data, sends it to you. What happens? You both are very happy. Well, my system now chokes up. Because when I get your schema, stop, your schema is not valid. But why is it not valid? Because you got this extra field. He's like, are you using this extra field? No. Then why are you complaining? Because I like complaining, right? So this is terrible programming practice. And we have gone down this route. It doesn't help evolve the system. On the other hand, you have a format, like a JSON format, for example. You send me data, and what am I doing? I use what I care about. Hey, there's parts of the data that I don't care about. Short answer, don't look at it. Don't look at what you don't care. Only look at data that you care about. Hey, I just changed data that you don't care about. Thank you, I don't care about it, right? So the point is, Postel's law says, be very generous about what you get. Don't go into rigorous validations, rigorous checks. It becomes a lot easier to work with when you are fairly loose in what you receive and manage that. And this is something we can do, especially in today's world, when we have messaging architectures, we really shoot ourselves in the foot. I've got clients who have done this, where they have a very strong coupling between parts, and they change one, and the entire system comes down. And they got to redeploy every single thing because everything is so tightly coupled and verifies everything, and complete violation of Postel's law. So that is something we can work towards. And of course, what about reuse? Reuse is the holy grail in software. Everybody wants to create reusable software. Grady Booch once said, create a software that's reusable first, then you can create it reusable. It's incredibly difficult. Why? Because to make something useful, it's got to be very specific. For something to be reusable, it's got to be fairly general enough. And that's a tension between the two. And we end up creating something really, really reusable, and in the process, it becomes absolutely useless. But if you really want to create something reusable, it should really come out of several multiple uses, and then you're able to get a chance to really reuse it. So don't rush towards reuse, refactor towards reusability. There are some really good examples of this around us to look at. If you think about this, imagine what happened to EJB. Nobody likes EJB. Why? Because there was no use for EJB when they created it. They got together and said, gosh, look at that. Microsoft has MTS. We need our own 3-letter acronym. Right? Oh, how about EJB? And we created EJB at that point. Well, but it didn't come out of any real use. And people started using it, and we landed into problems with it. But on the other hand, take a look at Ruby on Rails. They didn't sit together and say, let's create Ruby on Rails. They went about doing their stuff. They started using Ruby. And they said, look, this is working. Oh, but this part sucks. Let's refactor it. And so they started refactoring and refactoring and refactoring. And eventually, out of that emerged a framework. In a very similar way, that's just not one example, exactly how Spring came about. When EJB was floating around and creating all these problems, Rod Johnson went around and said, hey, why don't we start creating POJOs and implement very simple logic around here and start doing very lightweight dependency injection. And he started using this idea in multiple projects, and out of that he extracted the Spring framework. So when you extract things from working software, it becomes a lot more reusable. But instead, you go out after reuse, it fires back at us and becomes extremely difficult. The last thing I want to talk about is something very close to my heart, which is minimize libraries and frameworks. I want to say, don't build what you can buy. Don't buy what you don't need. So this is something very easy to get into, and we have to really work towards that. So don't build what you can buy, and don't buy what you don't need. And the word buy, I'm using it very loosely. Buy is equal today to download today, right? So let's be careful. When I was a young software developer, there was no internet. I mean, this is really hard to tell because my children look at me like, wow, you were born that long ago when there was no internet. There was no internet when I was a software developer, as a young software developer. And we couldn't download software. If I had to use a software, I had to make a request to buy software. And then I would have to wait for the tape drive to arrive. And I have to then take the tape drive and insert it and install the software. And you know what? You thought several times before you had to do it. Because nobody likes to spend the afternoon by the tape drive machine, right? And it costs money to buy these software. So we use less of it. I'm not suggesting those days were better because of that. But what are we doing today? You're working on something. Hey, look, I found this new library. What does it do? I don't know, but it's cool, right? I was recently talking to a developer. He said, when we used to run automated tests, I said, why are you saying used to? Oh, because all the libraries we are using in this JavaScript project, they quit working with automated test. I said, all the libraries, how many are you using? And he kind of stared at me for a minute. He didn't tell me. I said, excuse me, how many are you using? And he whispered, 150. I said, what? One project, he's using 150 JavaScript libraries. And he was honest about it because I could see pain in his eyes. I said, are you kidding? He opened his grunt file and showed me. Oh, I was scared. And I said, why are you using that many libraries? He said, because we could find them, right? And it's scary, right? When people begin to use that many libraries. And projects become really hard to maintain over time. So there's a balance here we have to strike. Should I use this library or should I not use this library? And this is bad like play all the time. I would rather use something than build it. But at the same time, I also have a dependency on it now. And 3 weeks from now, I decide to upgrade my framework, and that little library doesn't work with it. It holds me back. I can't tell you how many times I go around the world, people come to me and say, hey, we're using Java 8. And the person next to him or her says, oh, we couldn't. It's like, why not? Because the libraries we use, the frameworks we use, are not Java 8 compatible. We're eagerly waiting for it to move. This happens every single organization I go into. There's part of organization that's moved on. How did you guys move? We don't have that many dependencies. And these other things which have dependency on a lot of libraries and tools, they get bogged down. So the more libraries you depend on, the more difficult it is to get things done. So be very, very minimalistic in selecting libraries and ask yourselves, can we live without it? If the cost of living without is much greater than living with it, then use it. On a recent project I worked on, I wanted to implement a little feature. And there was an immediately available library for me to use. In 5 minutes, I can download it, bam, it's done. And I said to myself, no, I don't want to do it. Well, why not? Because I don't want to bring in extra dependency. Well, how much time it's going for me to build it? My estimate was it's going to take me 2 hours to build it for my own purpose. And I set a time limit. I told myself, if I'm not done in 2 hours, I will download and use the library. And I was done in about 2 hours, lucky day. But that's something to think about. Evaluate the cost of using it and the cost of maintaining it moving forward. There's a cost of maintaining your code as well. But there's some benefits to my own code. It's fully tested. It doesn't use anything extra. It's evolving with the framework and libraries I use. The third-party library is not. How many times have we seen this? Your library is not compatible with your version of language you are using. Oh, I can't move right now. Why not? Because so the more number of libraries you have, the more difficult it is to move. That becomes really hard as well. So that is something to think about. So to summarize what we talked about, we want to really evolve architecture. There is a cost of evolving. There's a cost of not evolving. We have to really be very cautious about it. We have to take the time to plan for evolving the architecture. Evolutionary architecture is not easy, but there's nothing easy in general anyways. But bring feedback, work with people closely, and apply some good principles and practices. Automated testing, for example, I alluded to it. It helps and promotes postponing things to the last responsible moment. And reversibility is extremely important. So when you sit down to make any design decision, include the word reversibility in it. Ask yourselves, is this decision reversible? What's the cost of reversing? What's the cost of not reversing it? And ask some of those questions. Refactor daily and dedicate time to do other refactoring to pay off technical debt. That becomes very important. Apply the Yagni principle and ask yourselves whether I need to implement a certain feature or a certain particular configuration, what have you. And also ask the question, hey, when I'm developing the software, how can I minimize what I depend on? How can I reduce my surface area? How can I reduce my coupling? How can I be loosely coupled? And so I can easily evolve when time comes to evolve it. Apply parsimony, apply Postel's law. Be very generous about what you receive so that the system doesn't become brittle and it doesn't hurt your extensibility moving forward. That can help you quite a bit as well. But it's a lot of fun to be developing software this way. It does take effort, but I always believe these are skills we get better at the more we practice and the more we evolve and learn, and it's a lot of fun to do. I hope you found that useful. That's all I have. Thank you.